Good day everyone. So in this video, I will show you an Excel program relating to design of axially loaded bars. So axially loaded bars have two types, tied column and a spiral column, which I will be discussing after this. We use 2010/2015 NSCP code in this Excel program. This code is slightly conservative compared to the former, meaning it has a slight decrease in the cross section of the beam and the number of bars needed. So to further emphasize the program, let's have an example. So design a square and spiral tied column to support an axial dead load of 1500 kN and an axial live load of 2500 kN. Use FC prime 21 MPa, Fy 415 MPa for vertical bars, and 276 MPa for spirals. Let's input the values: 1500 kN of dead loads, 2500, and FC prime of 21, and 415 MPa for vertical bars. So according to the code, if we use a diameter of main bars which is greater than 32, then we need to use 12 mm diameter lateral ties. If it is less than or equal to 32, then we will going to use 10 mm diameter lateral ties. So let's move to the calculated values. So steel ratio is equal to area of steel over the gross area. Thus we can equate area of steel is equal to steel ratio times the gross area, which we can use in this equation. So we can calculate the ultimate load capacity using 2010/2015 NSCP code, which is equal to 1.2 dead load plus 1.6 live load. So having this, we can have the gross area 432,436 mm squared. Having this gross area, we can now design the beam which has a cross section of 660 mm. So this is rounded to the nearest tens. And if we use 32 mm diameter bar, then we need to use 11 pieces of it. And the spacing of the lateral ties is 480 mm. So in conclusion, if we use 32 mm diameter bars and 10 mm lateral ties, use 10 mm diameter lateral ties spaced at 480 mm on center. Let's say we use 36 mm diameter main bars, then we only need 9 pieces of bars in this diameter, and the lateral ties is spaced 576 mm on each other. So now let's proceed to the spiral column. Again, using 2010/2015 NSCP code and the same loads and added steel covering and spiral bars, we have, and assuming a steel ratio of 0.02, we have the ultimate load capacity 5,800 and the gross area 352,732 mm squared. So in the design, we have the diameter of the beam 670 mm, the core area, the new gross area, which is calculated using the new diameter of the beam, the area of the steel bars, and the nominal steel ratio. So if we use 32 mm diameter main bars, we need 9 pieces of it to withstand these loads and stresses. And the core diameter is 610 mm, the S 70, and the S clear, which is 60, which is calculated using this minus the diameter of the lateral ties. Say we use 36 mm, then we only need to use 7 pieces of 36 mm diameter bars, but the S clear is 90, which is not allowed in the code because the only allowed value is greater than 25 but less than 75. So if we use 32 mm with 10 mm lateral ties, then we have S clear of 60 mm and it is okay. So that's all. Thank you.